So now let's proceed to the question 1. You have two functions, which is pi minus f in the bracket square over 4 with the range of x 0 to 2 pi. And the second one is the fx equals to pi square over 4 with the range of x 2 pi to 4 pi. If you notice the first function, when you expand, you will get x square minus 2 pi x plus pi square over 4. So the terms of x square going to tell you that it is a quadratic function, and later in the sketching graph you will have the curved line, and also the pi square over 4, it is the linear one, so you will get the straight line in the sketching of graph. So in this question also, it stated that fx is equals to fx plus 4 pi, which is x plus p. So the period of this graph is 4 pi. Now we are going to sketch the graph. So what we need is that the value of the curved line and also the straight line. So if you calculate the second function, pi square over 4, we will get the value of 2.47. And for the curved one, in these cases, I'm going to substitute x with 0, pi over 2, pi, 3 pi over 2, and 2 pi. So when you calculate, you will get the y value. So after that, we sketch the graph. So the graph is going to get like in this slide. And if you notice the graph, it will show you the period of the 4 pi. So if you calculate the L is equals to P over 2. 4 pi over 2 is going to give you 2 pi. So the value of L in this case is 2 pi. Note in this question, to expand the interval of negative 4 pi to 6 pi. And when you expand the pattern of the graph, you will see it is the neither odd or function. So the graph shows the basic Fourier sine series. So now let's move to the integralment. You will have to calculate the value of E0, En, and also Bn. So E0 will give you the formula of 1 over L integration of negative L to L fx respect to dx. So if you notice in this question, give you the two functions with the range of continuous. So it notes to you that it is a piecewise function. So first integration, you will need to calculate 1 over 2 pi integration of 0 to 2 pi x square minus 2 pi x plus pi square over 4 ds. And the second function, integration of 2 pi to 4 pi pi square over 4 dx. If you want to make your calculation becomes easy, you can also factorize 1 over 4. So when you do the correct integration, you will get the value of A0 is equals to pi square over 3.
So I'm going to show you how to find An and Bn. So by using the formula An stated above, we determine the L and then substitute the L and Fx into the formula. So and then we have to know which one is u and which one is dv. And then x squared minus 2 pi x plus pi squared is u, and then the cos n pi x over 2 pi is dv, and then u is meant for differentiate, and then after we have to differentiate until we find 0. So that's mean we have to integrate for 3 times. So after we settle integrating and differentiating by using the by parts method just now, we have to substitute again into the formula, but we have to know about the sign. So if this positive sign, we start with positive sign and then negative sign and then positive sign, but this negative meets with negative, it become positive, and then we just substitute inside here, and then we have to settlekan, and then we have to settle until we get the An value, which is A over n squared cos n pi plus 1 over n squared. Okay, so now we are going to find Bn. So Bn is using another formula, and then we also have to find the L, and we have to substitute the Fx, and then again find the U, find the dV, and then differentiate and also integrate by using the integration by parts. And again, by using the same technique, we have to know the sign, and then this positive, negative, positive, and then negative makes negative become positive, and then we have to substitute all the equation into the formula, and then we have to integrate and all to find the final Bn. And then this is the final Bn as shown at the photo beside. So this is the final Bn. The final step of this question is to find the fx. So after we have the fx formula must include the a naught. The formula have a naught, an, and bn. So that's why we have to find the a naught, an, and bn. So after we have find all the equation before this, we have just to substitute into the formula, and after that we have the final answer for the fx. That's all. Thank you.
Hi, my name is Nurul Wakila Amira binti Ahmad. So I will explain for the question B that have a waveform of predict function y equal to fx, and given the following table, which is s0 and fx value. The s0 started from 0 until 330, and the value of fx is started following by 0.8, 0.6, 0.4, 0.7, negative 0.9, negative 1.1, negative 0.8, 2.3, 3.5, 4.1, 1.5, and the last one is 0.9. The question asks to find the Fourier series for fx and second harmonic in the standard form. The value for a1 and b2 is given, which is a1 is 0.25 and b2 is 0.92. And also all the calculation must be in the 2 decimal places. So I will proceed to the calculation part. The first thing first, we have to build a table for x naught, fx, fx cos 2x, and fx sin x. Because we want to find the value for a2 and b1. So to find the value for a2 and a2 and b1, we must have a summation for fx cos 2x and summation for fx sin x. So this is all the value that we have if we substitute the value using the formula into the calculator. So the summation for fx is 12.00, and summation for fx cos 2x is negative 5.70, and summation for fx sin x is negative 10.01. In this calculation, we must calculate the value of a0, c0, b1, a2, c1, c2, alpha 1 and also alpha 2. A1 and B2 is given. So first we have to find the value for A0, which is A0 equal to 1/6 multiplied by summation Fx. Substitute the value for summation Fx, which is 12.00, and we got the answer is 2. And then move to the C0. C0 is equal to A0 over 2. So substitute the value for A0, which is 2.00, and then divide the value to 2, and we got the answer is 1. And next, proceed to the B1. B1 is equal to 1/6 multiplied by summation Fx sin x, and we substitute the value for summation fx sin x, which is negative 10.01, and we got the answer is negative 1.67. And for the A2 is equal to 1 over 6 multiplied by fx cos 2x, and we substitute the value for summation fx cos 2x, which is negative 7.0, and we got the answer is negative 0.95. So let's proceed to the Cn. Cn is equal to SET an squared plus bn squared. So for Cn is a SET 0.25 squared plus negative 1.67 squared. And we got the answer for C1 is 1.69. And for the C2, SET negative 0.95 squared plus 0.92 squared. And we got the answer for C2 is 1.32. So, for the alpha 1 is equal to inverse tangent A1 over B1. We substitute the value 0.5 and negative 1.67, and we got the answer is negative 8.51. This is case 2, which is quadrant 2, and 180 degree must be minus with 8.51 degree, and we will got the answer for alpha 1 is 171.49 degree. So move to the next, which is alpha 2. Alpha 2 is equal to inverse tangent A2 over B2. We substitute the value of A2 negative 0.95 and B2 0.92 in the formula, and we got the alpha 2 is negative 45.92 degree, and in the case 4, which is quadrant 4, and we have to 360 must be minus with 45.92 degree, and we will get the answer is 314.08 degree. So we must write back in the second harmonic form, which is fx. Fx is equal to C0 plus C1 sine open bracket x plus alpha 1 close bracket plus C2 sine open bracket 2x plus alpha 2 close bracket, and the fx is 1.00 plus 1.69 sine open bracket x plus 171.49 degree close bracket plus 1.32 sine open bracket 2x plus 314.08 degree close bracket, and this is the final answer for this question. Thank you.